Okay, so R from P is 135, and the angle PQR is actually 55 degrees. So PQR 55 might actually end up being something like that. Okay, and then after that, angle PRQ is 48 degrees. Alright, there are actually two cases that we need to look at. Alright, so let me draw out the first diagram first. Okay, so one way is to have the diagram drawn in this manner, right? Where we have 48 degrees here, and then also 55 degrees over here. Okay, in part A, we want to find out what is angle, the bearing of P from R. So P from R so we will have the north line somewhere here. So we are looking for this angle here. So what I did was to first find out what is the angle here, okay, which I label as alpha, and I got 45 degrees. And then after that, what I could have done is to take that alternate angle to see that this is actually going to be an alpha also. So therefore, the bearing of P from R will be equals to 360 degrees minus away 45 degrees. And I would have 315 degrees, right? Angles from a point. Okay? Then for part B, when I want to find out what is the bearing of Q from R, that means I need to find out this angle here. Okay. So in order for us to find out what is the angle, we need to know. Okay, we can do that by realizing that because this alpha, alternate angles, right, one is 45 degrees, so this remaining angle would actually be 48 degrees minus away 45 degrees, okay, which we get the bearing of 003 degrees, right? There are actually many ways that you can do. Okay, so it's dependent on yourself. It's not limited to just this. Even what I write over here is not the same as what I have on my answer over here. Okay, so in part C, we want to find the bearing of P from Q. So from Q itself, P from Q, that means we are supposed to be looking at this angle. Okay, so in order for us to do that, we will find, okay, we can see that because this angle that we have found in part B is actually 3 degrees, so down here is actually 3 degrees as well due to alternate angles. Right, so therefore the bearing of P from Q would actually be 180 degrees plus 3 degrees plus 5 degrees. So we get 238 degrees. Okay? So So the diagram to support your working would be very important. If you have a very badly drawn diagram, do not expect any marks to be awarded, okay? Because the diagram will support your explanation. So this is just the first case. There is a second case as well. So in the first case over there, right, what I saw was that I saw the 48 degrees as being inside here, and then after I had my Q on the upper right hand corner, okay. Alternatively, okay, of course I can also have it on the other way around, such that PRQ is about 48 degrees, okay. Hence I can have maybe an angle that is maybe around like that. Okay, so angle PRQ and Q will be around here, and then after that, this PQR has to be 55 degrees. Okay, so we look to finding out all the same bearings as well. So bearing of Q, hang on, bearing of P from R remains unchanged. So from R itself, the bearing of P will still remain as this. Okay, so it still remains as the same way of finding, where I can find out what is this angle alpha, alternate angle to here, alpha. So alpha is equals to 180 minus 135 degrees, and we get 45 degrees. So I transfer it over here, and then after that the bearing of P from R would be 360 degrees minus away 45 degrees. So actually the work is exactly the same. This is angle 7 point. Okay, then after that for part B and C, that is where there are differences. So in part B, we want to find the bearing of Q from R. So Q being here, okay, from R itself, that means we will be trying to find this angle here. Okay. So earlier on we already found the bearing of P from R, which is the entire purple arc, okay, that reaches up to here. So since we know that this part here is 48 degrees, what we can do is to take the answer from part A minus away 48 degrees. Yes, of course, we have to draw both scenarios. Okay, this question did not limit you to having only one scenario. You need to have both scenarios. Okay, and that is the problem when diagrams are not given. Alright, then in part C, okay, we want to find the bearing of P from Q. So P from Q itself, and Q we draw in our north lines. Okay, so we are trying to find out what is this angle. Okay, to find out what is this angle here, let's say I call it beta. Okay, it is actually going to have alternate angles to be this angle here. Okay, I can find out the angle of QPR. which is 180 minus 55 minus away 48 degrees. Okay, and I will get 1 is 0 minus 55 minus 8, 77 degrees. Okay, then after that, to find out the angle beta, it will be 77 degrees minus away alpha, which is 45 degrees. And we get 32 degrees. Okay, so therefore the bearing of P from Q is equals to 032 degrees. Okay. From point P to point Q on a bearing of 128 degrees. Okay, so this is a length of 30 km. Alright, it then flies another 25 km to a point R on a bearing of 295 degrees. So that means from Q itself, okay, there is a bearing of 295 over to point R. Right, so that means from the north line over to the point R, okay, this angle here will be 295 degrees. Right, it doesn't say where does it stop actually, so we can only draw a rough diagram to understand how it can possibly look like. Okay, so this is a draft that I have. Right, then after that, we want to find the distance between P and R. So in order to do that, okay, we need some angles to be inside the triangle first so that we can apply any sine rule or cosine rule that we want. Okay, since we actually have two sides already, what we can do is to see if we can find out what is this angle here. Okay, if I can find out what is this angle here, then I will be able to use a cosine rule to achieve the length of PR. Alright, so let's look at whether we can find the angle. Okay, so since we know what is 128 degrees, since the north lines are parallel, and we have this line connecting from P to R, P to Q, I can find out what is this angle here, okay, by making use of interior angles parallel lines. So if I were to label this as alpha, I will get the value of 52 degrees using that property that I mentioned. Right? So then angle PQR would just be 360 minus 52 degrees minus 205 degrees. And I would be getting angle, what's the value? 30 degrees. Okay, so I get angles at a point. Then after that, following from there, I can use my cosine rule. we get 7.97 km in 3SM. Okay, in case you're wondering, like for example, question 10, right? Okay, we have to draw a diagram to guide ourselves so as to visualize the situation. Okay, likewise, earlier on in question 7, we also had to do the same thing. But why is it that question 10 only had that one case and then for question 2 we had 2 cases? Right, the reason is because for question 7 earlier on, there was that difficulty in deciding where Q can possibly be. Okay, Q can either be placed on top or at the bottom. So it can go in a clockwise manner PQR, or it could actually go in an anti-clockwise manner PQR. Right? So that is that variation in question 7. Whereas for exercise 7b question 10, right? Okay, there is no variation because it is actually fixed already. They told you P and Q how is it related, and specifically they told you for the third point R how it does it relate to Q. Okay, there is no way for us to have another situation where R can be placed elsewhere such that this still has a bearing of 295 degrees. Okay, earlier on, they did not give you the bearing for the third point. Okay, with reference to any other 2 points. Right, so because of Q having no bearing reference, it only has reference to the interior angles of the triangle. That's what makes it having this fluidity for question 7 in comparison to question 10. Alright. Then next we look at question 13. May I know for question 13 which part is it that has an issue to it? Question 13, which part? Somebody asked for question 13, right? Zhen Xue, which part? You tell me who thing. Part? 1, 2, 3. Okay, yes, Joseph? 3 and 4. 3 and 4, okay. And let's take a look at part 3 and 4. From B and C, and part 2 we found angle ABC. So in part 3 we want to find the bearing of C from B. So okay, my diagram not very well drawn. Let me draw something better. Okay, so to find the bearing of C from B itself, that means that from B we will have this angle here that we need to find. Okay, in order to find the angle, what we can do is to find out what this angle is here. Okay, by using interior angle property between 68 degrees and then with the parallel lines. Okay. So we will get, if I have this as theta, 180 minus 68 degrees, and I have 112 interior angles parallel lines. Okay, then after that, after having the angle, I would need to have angle ABC in order for me to use angles at a point. Alright, so are we able to find the angle ABC? Okay, earlier on in the questions, okay, I don't know about yourself, but I have actually found out what is angle CAB as well as angle ACB. Okay, so angle ACB was supposed to be 40.49. Can someone give me better accuracy? 40.49 what? For part 2 answer? 0. Okay, thank you. Alright, then after that, in part I found out angle angle CAB is 76 degrees. Okay, so therefore angle ABC will be 180 minus 76 minus 40.490. And that will be 63.51 degrees. Then after that I can use angles at a point. I get one at 4.5 degrees. Then after that, to find part 4, the shortest distance from A to BC. Okay, Joseph, can you tell me what methods can I use to find the shortest distance from A to BC? What concept will I need to use? Area, okay. Because shortest distance is always the perpendicular distance, right? Okay, so if I want to make use of area, then I will need to do half AB sine C, okay, which is possible because I am aware of the length of this and I'm aware of the length of this, and I have the angle over here. Okay, and then to find out what is the base, if I want to use half times base times height, okay, I need to know the length of BC, okay, which I have already found in part I. Alright, so I will form my equation. Okay, equals to half times BC times the height that we want. Okay, could I leave this to yourself to do the calculation? Right, yes, Sir
I don't understand why you use 112 degrees.
You don't understand why? What?
I don't understand that. How you use the 112 degrees.
How I use the 112 degrees. Where this 112 degrees came from? This one. You don't understand how I got 112?
No, I don't understand that. Why you use 112.
Why I use 112? Otherwise, what are you suggesting? Sorry, it's a bit difficult for me to understand what you're trying to say. Try very hard over here. And it's being worse with the athletes. Can you repeat yourself? You don't understand why is it 112? I need you to speak louder. Okay, can. So angle PAC, right? Okay, we have this thing on the top. And we have P here. So we want to find PAC. Okay, so to do that, okay, Joshua, what could we do to find angle PAC since you are variable? Use what? Tangent, how? Find what? Tangent. Angle PAC, yes. I hear a single word, yes. Okay, so you find the length of AC first. Okay, and we get the value of 20 for AC. Okay, so AC is 20 cm. Okay, so after we find out what is AC, we need to realize that PAC itself is an isosceles triangle, where the length PA is equal to the length of PC. So therefore, having this 20 cm, okay, I can divide it into two parts, okay, 10 cm, 10 cm each, right? Then after that, from P all the way to the bottom, okay, if I were to label that as M, right, I will have the height of 5 cm. Okay, and then after that, AM is actually 10 cm, as mentioned earlier. Right, so then after that, I can use tangent equals to opposite over adjacent to find out what is angle PAC. Opposite is PM, sorry. So angle PAC will then be about 26.56 something. Can someone give me the fifth significant figure? 5, is it? Thank you. Okay, I got 26.6 degrees 1 dp. Alright, then after that, for part 2, where I want to find angle PAB, which is this angle here. Okay, taking note that it is on a slanted surface. Okay, PAB is a slanted triangle. Okay, lying in that cuboid. Right. So for us to find out what is angle PAB, okay, I can find out what is the length of AP. Okay, relying on the triangle, the right angle triangle PAM. So what I will do is PA is equals to the square root of 10 squared plus 5 squared, and we have square root 125. Okay, you may leave it in exact if you want to, or truncated 5SF, up to you. Okay, both accuracy are fine. Right, then after that, we need to know that, sorry, PB equals to AP. Okay, then after we need to realize that PB is actually of the same length as AP. So then to find out what is the angle required, we can use cosine rule. And we have PB squared equals to PA squared plus AB squared minus 2PAAB cosine angle PAB. So this is going to be 125 equals to 125 plus 12 squared minus 2 times square root 125 times 12 cosine angle PAB. Okay, then I'll leave it to yourself to do the calculation. Right, angle PAB would be 57.5 degrees, 1 dB. Yeah, you still call me Miss Liao? Yes. You segment out triangle PAB. Yep, that's fine. It's also an isosceles triangle, no problem. Okay. Any questions? Right, then let's see question 11. Question 11, may I know which part AB? May I know what's the issue for question 11? Who asked it earlier? Question 11, who asked? Nobody asked? About 11? Then can I not go through question 11? Calling out again? Did I see your hand just now? I saw. Amanda, did you ask question 11 for exercise 7C? I asked so many times that nobody raised hand. So, do you ask question 11? You asked question 11, right? Yeah, now that I remember. What is it? Which part is it? I can't hear you. I can't read your lips. For? All. Okay, question 11. Given this diagram, part I, we want to find the bearing of A from B. So at B itself, we draw our north line, and this is the angle that we need to find. Okay, question says that O is actually due west of B. Alright? So, or rather B is due east of O. Okay. So, what we can do is to first find out angle ABO. Which is this angle here. Okay. And since triangle ABO is a right angle triangle, we can use Picasso. And that will be a tangent inverse of 28 divided by 30. And we get 43.025 degrees. Then next, we find out what is the angle here. Okay, because after we get this to be 43.025 degrees, right? Because it says B is due east of O, so therefore this must be 90 degrees here. Okay, and finding out the angle theta, it will be 90 degrees minus 43.025 degrees, and we have 46.98. Or rather 46.975 degrees. Okay. Then finding out what is the bearing required will be 180 plus 46.975 degrees. 7.0 degrees, 180. Okay, then after that in part 2, we want to find angle COB. Which is this angle here. Okay, so we can apply our cosine rule. Leave it to yourself to do the finding the angle, okay, after applying cosine rule. At the end, you should find the angle COB is 120 degrees exactly. Okay. Then part 3, we want to find the bearing of C from O. So at O, we will have a north line. C from O, that means we are looking for this angle here. Okay, so since we have already found out what is angle COB, which is 120 degrees, okay, we can find out what is this angle here, the reflex angle of COB, which is 360 degrees minus 120, we get 240 degrees. Then from there, okay, we are only short of this particular part to contribute to the bearing. So that particular part is actually 90 degrees because after all, OA is actually a straight line, okay, in the sense that A is directly due south of O, alright? So therefore, the bearing would be 90 degrees plus 240 degrees, and we have 330 degrees. Okay? Then lastly, there is a vertical flagpole standing at point B, such that the angles of elevation of OA and C are measured. So at point B itself, we need to see that there is a vertical flagpole. So this is a 2D diagram. If it becomes a 3D, so it's standing upwards like that. Okay, then after that, given that the greatest of these three angles of elevation is 29 degrees, right? So it is at B, then after that, they measure angle of elevation from point O, A, and C, right? So we need to find out what is the height of the flagpole. Okay, so understanding how the greatest of angle of elevation occurs, right? It occurs when you are the closest to the flagpole itself. Okay, where the distance between the point to the flagpole is the closest. Because you imagine you stand in front of Mr. Hardep Singh. Okay, he is a very tall man, right? If you stand very far away, you don't have to raise your neck very up high to look at him. Okay, but then if you stand very close to him, alright, you have to look up very high. Okay, you need to tilt your head very high in order to look at him in the eye. Alright, so therefore, by the same logic, okay, we are looking at the closest distance to B, alright, in order to have the greatest angle of elevation. Okay, so looking at these 3 points, A, O, and C, it will only happen when it is at O, okay, because that is going to be the shortest angle of shortest distance. Okay, so to write that down, itself, you can just simply compare the length. Okay, so the length CB we have found, we are given it to be 70 meters. OB is actually 30 meters. And AB, right, we can use Pythagoras theorem, 30 square plus 28 square, and we get about 41.03 meters. So looking at all this, it is clear that O is the shortest distance to B. So after deducing that, we will then be able to draw a right angle triangle. Okay, this is point B, this is point O. Flat hole looks like that here, and we get a right angle triangle like this. The length OB is given to be 30 meters. We want to find out what is the height of the flat hole. This angle here is actually 29 degrees as given in the question. So tangent 29 degrees is equals to height of flat hole over the length 30. So leaving you to do the calculations, the height of flat hole will be 16.6 meter when rounded to 3 SF. Okay? Any questions? Alright, can you please pass down your chapter 7 homework first? Okay, people at the front, please help me to sort them out. Regarding the arc length and sector area. So let's see. Wait for the pen. B, C, B, C. Oh, that was all. Thank you. Yes. Okay. Question exercise 8A. Any problems with exercise 8A for arc length? Arc length, any problems? No? So formula can accept, is it? Exercise 8A, okay, huh? The questions were question 3B, 5, 8, and 10 and 15. 15 is okay? Alright, amazing. Alright, questions, exercise 8B. Exercise 8B on sector area. Question 9, 10, okay, 10, 12. So question 10 only?
Question 9.
Question 9?
Yeah, question 8.
Question 9, right? Exercise 8B. Question 9, right? I gave?
I gave it.
Yeah, give question 8. Question 9, right? Oh, so then you're looking at this thing. Yes. 12. Okay, so 10 and 12. Alright, sure. show the angle PAB. Oh, okay. So let's take a look at that. Okay, so angle PAB, this one is PA. Okay. So angle PAB is this one here. What we should do is to chop it into a rectangle and a triangle. Okay, such that the triangle is the right angle one. Okay, so that I can find out what is this length here. Right. So if I were to label this as x, that would mean that AX is actually 11 minus 7, and I get 4 cm. Okay. Then after that, AB itself, right? Okay, you need to realize that A is actually the center of the big circle, and it reaches the circumference of the circle. So therefore, this length here is 11. And then after that, for B, it is the center of the smaller circle, and then it reaches the circumference of the circle itself. So therefore, this is the radius 7 cm. So the length of AB would be 11 plus 7, that's 18. Okay, so now that I have the information for the right angle triangle, where I have 4 cm here and 18 cm here, okay, then I can use my Picasso to find out the angle of PAB. So angle PAB will be using adjacent over hypotenuse, that is cosine. Angle PAB will be adjacent for hypotenuse 18. So angle PAB would be cosine inverse of it, and we get 77.2 degrees to 1 degree. The truncated 5SF is 77.160. Okay, so this is part A. Next, for part B, or rather part 2, okay, we want to find the area of the shaded region. And the shaded region is in between the two circles. Okay, so to find out what is this area, we would think of probably finding the area of the entire trapezium first, then minus away the two center areas here. Correct? So let's go about finding the area of the trapezium. Okay, area of the trapezium formula is half times sum of parallel lines times height. Okay, but the height, which is perpendicular, is actually the length PQ, which we do not know. But we can find it because it is the same as this length in the right angle triangle. Okay, so the height would be square root of 18 square minus 4 square, and that would give us 17.54 something. $75.549. Okay, so therefore the sum of the parallel lines will be 11 plus 17. So area of trapezium would be half times 11 plus 7 times 17.549. Okay, and we get 158.211. Right? Then after that, we need to find out what is the area of the sectors. Okay, to find the area of the sector AP to, let's call this point R. Okay. Right, would actually be using the angle PAB over 360 times pi r squared Any issues at this point? We get about 81.475. Okay, then the area of the sector RBQ, right? We need to know what is the angle of RBQ, and the angle of RBQ would actually be 180 minus away 77.160 because we have parallel lines and we can apply interior angles of parallel lines. Okay, so the area of sector RBQ would then be 102.84 degrees over 360 times pi times 7 squared. Yep, sorry. Half times, did I get it wrong? 11 plus 7, right? Did I press wrongly? 18 plus 17 is times 17.549. 1578, what did I not get this one? 157.941. Thank you. Okay, so then this one times pi times 49, we get 43.974. Okay, and therefore, area of shaded region would be 157.941 minus away 81.475 minus 43.974. And we have 32.492 cm squared. Right? Any questions? So, head to okay, you find that question 10 actually is a very difficult question also, right? Then after that, we wanted question 12 also, right? Question 12, may I know what is the part that you don't know how to do? Who asked? You asked just now, right? Zhen Xuan.
Part 3 and part 4.
Part 3 and part 4, parameter of the shaded region. Okay. Are you able to find the arc length of BQ and BP?
No.
You can find?
No. I cannot find BQ.
You don't know how to find BQ? Okay. Do you know how to find the angle of BOQ? Wait. Yeah, angle BOQ we have part I already, ma. So you have the diagram with you or not? You do have the diagram. Then if you have the angle of BOQ, then you can find arc length of BQ already, ma. I don't know what you're looking at there. You got a picture printed in your brain, is it? Okay. Why not? Because of the time, alright, time constraint. Okay. Anybody else needs question 12? Actually. If not, then I'll maybe go through question 12 or I'll just write in your work when I mark it. Okay, so can you please submit exercise 8A and 8B, right, to the front now, right? Then after that, for exercise 8D, right, okay, do you have any issues with gradient measure? 8D, maybe I'll do it tomorrow. Okay, so 8D, submit tomorrow.